Okay. Hello, everybody. So we're trying something a little bit new for this seminar. We have our live participants here in the Innovation Hub in Hagahelia, and then we also have about 50 people registered online as well. So we're having a bit of a hybrid seminar today. My name is William O'Gorman, and I'm the Applied AI for Business and Education Innovation Hub Manager here as part of the Ulysseus European University Alliance in Hagahelia. You're all very welcome here today, both physically and virtually, to talk about our UlysseusAI Joint Master's Degree. We're going to have some interesting conversations and some presentations. I'm just going to give a little bit of a welcome and introduction to the Innovation Hub. Then we have Lily Einemo from Hagahelia, who's going to give a presentation on the Joint Master's Degree itself. Then we have our visiting professors from MCI in Innsbruck, Stefan Schlögl, who's going to give a presentation about acceptance, trust, personality, and gender. And then we're also going to have a presentation from Dr. Jan Magyar from Technical University of Košice about giving people the education they need. And then finally, we're going to have Lily Einemo again giving us one last round about what affects study completion times. The schedule is pretty flexible, and we're very open and eager for participants both in the room and online to please ask questions. If you're in the room, put up your hand. I'll come to you with a microphone. And those of you who are online, please just write your questions in the chat, and we'll get around to it at the end of each of the lectures and presentations. I hope everything is working okay online, that you can all hear and see. And yeah, it's a pleasure to have everybody here. So we'll get started a little bit. So I'm going to give a little bit of an introduction to our Innovation Hub and also to Ulysseus. So Ulysseus is actually a 10-year journey that we began, maybe 5 or so years ago. Ulysseus is part of the Erasmus Plus European Universities Alliances. It's going to take in 3 stages with the main goal of developing a new European university for the citizens of the future. We're kind of in the midpoint now. The first stage took about 3 years, and we've got 4 years. And then after that, we hope it's going to exist forever. So it's been a big project, a big alliance, a big development of cooperation between all of our 8 partners. And one of the key elements that is this UlysseusAI Master's Degree, which we'll talk about later. But underpinning all of this is that we want to develop with our 8 university partners one joint vision for the future. We also want to develop joint and double degrees and open online courses to benefit all of our students in all of our 8 partner organizations. And also we want to focus on international mobility, both physically, blended and virtual. It's a very important part of what we're trying to do. And then what's close to my heart is the joint research. We have this joint innovation ecosystem, which I'm going to show you a little bit about, and also EU funding from the EU, which we call satellite projects. So we have our 8 Ulysseus Innovation Hubs, 8 Ulysseus Innovation Partners, and then each one of our partners also has its corresponding innovation hub. We're very fortunate here in Hagahelia that our innovation hub is based on applied AI, which is a huge topic in education and in business, and something that we are doing our best now to research and to develop cooperation between business and education. We want to focus on developing incubators and living labs to test AI. Our goal is to involve students and teachers, but also we want to provide research opportunities based on applied AI in business and education, and that's the role of our Innovation Hub. How we're going to do this is we're going to try and develop and receive grants and funding for EU projects based on AI, business and education, and we want to do this through facilitating the 8 partners in our innovation ecosystem throughout Europe. So it's a really great achievement, and I think it's been going pretty well up until now. But that's enough about the Ulysseus Innovation Hub. I'd like to invite Lily Einemo here to give a talk to you about the introduction to the new Ulysseus Joint Master's Program in AI for Business Information Transformation. And please, if you have any questions, just ask them on the chat, or anybody in the room, just put your hand up and we can have a go. So please, I'd like to invite Lily to the floor. Hello, Lily.
Hello, thank you. So, good afternoon also from my part. I am Lily Einemo, a principal lecturer here in Hagahelia, and I am the academic coordinator of this Ulysseus Joint Masters in AI. And as William said, this is one of our joint degrees, is one of the core activities of the Innovation Hub alongside with research. So I will be presenting this new joint master's degree, which will start in January. And then actually the other talks for today by Professor Stefan Strögl and Professor Jan Magyar will be given by the academic coordinators at other institutions of this UlysseusAI program. So, about this master's degree, well, it has a very strong European viewpoint in it, and the student will gain a degree from Haaga-Helia University of Applied Sciences, from the Management Center of Innsbruck in Austria, and from the University of Seville in Spain, and also the University of Košice in Slovakia is involved in delivering the degree. And here you can see how this is arranged in practice. So the students will spend their first semester here in Finland, in Haaga-Helia, starting of January 2025. And after that, they will be moving to Austria, to the Management Center Innsbruck for the fall semester. We call it fall semester in Finland. And then after that, they can choose if they go to TUKE, the Technical University in Košice, Slovakia, or if they go to Spain, the University of Sevilla. And for the fourth semester, they are free to choose where they are. It typically might depend on, for example, the topic of their thesis project. If they are doing it, for example, for some R&D project in some research lab of the Ulysseus University, or if they are doing it for a company where they are working, or to another, or where their main advisor is. So they are free to choose for the fourth semester, and they can also be in some other country than these four aforementioned ones. And here is some details about the contents, how it is organized, and what type of topics the students will be studying. So at Haaga-Helia, we will start with the basics of AI in business, and also we will deliver mathematical principles for machine learning here, and then the Management Center of Innsbruck will continue on what we have been teaching the students, and they will go deeper into the technologies and other topics. And then, as said, in Košice, the more technically oriented students can learn about different methods and algorithms deeper, and those who are more interested in different applications will go to the University of Sevilla to learn about how to apply the different methods in different AI systems, such as recommender systems, for example, or text analytics, for example, as such. And then, of course, the degree also involves transversal studies and elective studies, and these can be provided online also, and the students are taking these alongside. And maybe what is quite interesting is the master's thesis. So the students are starting with studying research methods and academic writing at Haaga-Helia already during the first semester, and then they will be continuing to think about research and looking for interesting thesis project during the semesters 2 and 3, but the actual writing will be done mostly during the semester 4, when they are almost done with other studies. And one of the supervisors will always be from Haaga-Helia, and the second supervisor will be from another Ulysseus university. So the student will have 2 thesis advisors. And in total, this degree is 120 ECTS, which is 30 ECTS more than most of the master's degrees offered at Haga-Helia. And this is a Master in Business Administration. Okay. And then here is some more detail about thesis, and it is 30 ECTS, as is usual in Haga-Helia. And then it will be done in an associated company. So we have in the advisory boards of this program, we have some companies. So we are cooperating especially with those companies very intensively to organize cooperation in teaching, in curriculum development, and also in the thesis work. But of course, we have all these Ulysseus associate partners also. And we also have other Ulysseus partners and their research labs that can offer thesis projects to our AI master's students. We have very actively involved in our advisory board also the University Côte d'Azur and also this University of Genova. So especially those will be very well integrated here, but also other Ulysseus universities can offer projects. Okay, and then this is the basics of the degree program, and then I am very happy to accept questions that you might have, and we can discuss this. So this is really why it's really nice to have people here in person, so that we can actually have some discussion here. And I think the online people may also have questions, and we can also take those. So now it's time for them.
So if you have a question online, please put it in the chat. Otherwise, anybody in the room have a question that they would like to ask Lily? Nothing in the chat? No, so I guess that's it.
Okay. Well, I see someone. Oh, sorry, William. Yeah. Great.
Hello, so my name is Irma, and I'm leading the pedagogical development group within Ulysseus. And we have been discussing what are the pedagogical principles in joint implementations. So how do you see what are the pedagogical principles you try to follow in your program?
Okay, that is yeah. I was thinking that this
quite an easy one to answer there.
This is a tough question, but well, of course, we are very much focusing on delivering a jointly European degree where the European values are present, and also the European cooperation is really very concrete. And in the pedagogical approaches, we are really very much also emphasizing the collaboration in the courses. So not only having separate mobility so that the student will be first in Finland, then in Innsbruck, and then in Košice, and then in Sevilla, and those would be like kind of separate exchanges. No, we are also collaborating through the advisory committee, so designing both the curricula and then the syllabus together with our international partners, also involving, of course, the business partners, so not only the universities. And then also we have plans, quite concrete already, to also deliver some courses in cooperation, so that there will be cooperation inside each program, and we will be also the student mobilities and also teacher mobilities can be used for this. I think this is something that is special for this. Otherwise, we are using the pedagogical approaches that are well known and very good in Haga-Helia and in the other institutions. And I also have the academic leaders, Stefan Schlögl and Professor Jan Magyar here. So if you want to add something to the pedagogical approaches, feel free. But this is, I think, what is really special for this degree that we don't have in other degrees, in other master's degrees in such extent here in Haaga-Helia.
Excellent answer to a nice difficult question. And actually, I have one more question for you, Lily, from the chat. So from Lucia Palas. So the master will be held in presence in each country, or we can choose to do a semester online and other on site.
Okay, thank you for the question, and that is really very relevant question, especially for the students. So you have to be present. The students have to be and have also the occasion to be present. So we offer lots of support for this in terms of guidance and support for on the housings and on the timetables of these courses, so they are really all planned so that it will run also smoothly from the scheduling point of view, because these universities have very different academic schedules also. So everything is really thought of so that the experience is smooth for the student. But the student is really in person, first in Finland, then in Austria, and then in either Slovakia or Spain. So in these places, and then the fourth is free choice. So for example, if the student comes from Finland, then he or she will be 1 year abroad during the studies. Yeah.
Great. Thank you, Lily. So we'll move on to our next speaker. Thank you very much, Lily.
Yes, thank you for this opportunity.
Okay, so next up we have our visiting professor from MCI Innsbruck, Stefan Schlögl, and he's going to give a lecture on acceptance, trust, personality, and gender, investigating inherent challenges of human-AI interaction. And once again, those in the room, if you have a question for Stefan, he's more than happy to answer. And those of you on chat, please, the more difficult, the better. So please, thank you, Stefan.
Thank you, William. Okay, thank you very much for the introduction. Good afternoon to everybody in the room here. Good afternoon to the people at home in front of their laptops and computers. I'm Stefan Schlögl. I'm a professor of human-centered computing at MCI in Innsbruck, one of the academic partners of the Ulysseus European University Alliance, and also one of the coordinators for this very novel new master's degree in AI for business transformation. I want to use the next couple of minutes to talk about not so much about this program, but about potential topics that could be investigated as part of a master thesis topic. For example, topics that are usually more relate more to the social science and managerial aspects of using AI, not so much to the technical aspects, but they have certain technical elements in it that need to be solved in order to have an effect on the business side of things. I entitled this talk Acceptance, Trust, Personality, and Gender, investigating inherent challenges of human-AI interaction, because these are things that I and my students and I have been investigating for the last, 7 years or so. And in order to start this whole journey, I would like to go all the way back into the 1950s. Those of you who are interested in AI and artificial intelligence in general or computing will know that the 1950 is basically the year when the first, a groundbreaking aspect of artificial intelligence was defined, the so-called Turing test by Alan Turing. At the time, it was not really called artificial intelligence. This domain was only founded in 1956, to be honest. But Alan Turing invented his test at the time. That was a bit like this. It was based on what we call the imitation game, where the challenge was to basically trick a human being, a human a dialogue partner, if you want, into believing that the counterpart is another human being, although it's not. It could be a computer. And so if a computer manages to trick somebody into believing that it is not a computer but a human being, then that's what we call the Turing test is more or less performed accurately. And at the time already, this was a lot about trust. In a sense, it's also a violation of trust almost, because I make somebody believe that this person is talking to a human being, but in reality, this person is talking to a machine. And just a couple of years back, when maybe you remember, there was a public presentation by Google about one of its new products called Duplex, and they were very keen on showing the whole audience in a big conference center how good their AI is by forming a live performance of an AI calling for a hairdresser appointment. And the hairdresser didn't know, like the person that was called didn't know that he or she was interacting with a computer. And Google was very proud about this. It didn't take more than a couple of days for the first people from the research community to shout out and say, well, that's ethically not correct. I have to make people aware of the fact that they are interacting with a machine and not with a computer. So there's a huge dispute about whether it's still okay to sort of mimicking human behavior, whether it's still okay to trying to simulate humans by computers. But that was the 1950s. We have evolved since then. Since then, 1960, in the 60s, there was the first software that actually cracked the Turing Award. In 1966, I see it in the room here when standing. I just noticed it when I came into this room. There's a wall with all the different dates, the important dates of AI, and 66 is there as well. Joseph Weizenbaum, at MIT, basically developed a rather simplistic chatbot that appeared to be human by using a simple trick, basically playing phrases back. So somebody would ask the chatbot something, and this chatbot would just simply play phrases back and turn them into other questions. So he kept a conversation going. Funny enough, people started building up some sort of relationship with this chatbot. It was basically mimicking a psychotherapist, not professional psychotherapist, but it kept the dialogue up and going, and people started to connect to this, and that was actually quite surprising. Almost 60 years ago. Then I make a big jump, because the upcoming 60 years were full of surprises, disappointment, and so on, because essentially we thought in the 60s that we would crack the AI sort of challenge within a couple of years. But there was a huge period called the AI winter in between, where all the hopes that we had in industry about a new technology that would essentially be intelligent, all these hopes were basically destroyed, because we realized that those problems that we tried at the beginning were really simple and small. But once you let them out into the real world, they become intractable. So they become too complicated to be solved by an AI. Why do I now jump to the 2010s? Because that's basically when we started when we started seeing sort of AI applications turning up for actual consumers. Apple being one of the first to introduce Apple Siri. Now, Siri was not an invention by Apple, by the way. They were just clever enough to buy a company and made it Apple, basically. So they bought up the whole company and prevented the company from offering their application on Android phones and at the time BlackBerry phones and so on. So they were early enough to just buy them up and offer a new kind of assistant on their phone. It was not so much the technology that was clever here that they bought, but it was clever to bring it out to millions of iPhones, because all of a sudden lots of people could use AI for real. And all of you who are in AI development know what this means. Lots of people start giving their data away. And that's what we need actually to build better sort of algorithms here. At the same time, more or less the same time, another big player in the field, Amazon, was hiring computational linguists. I was doing my PhD at the time, working for a European technical university, and I was wondering why would Amazon hire computational linguists? I mean, they are an e-commerce provider. A year or so later, I knew why, because all of a sudden they announced a product called Alexa, which to a certain extent brings me to the first studies that we have done at MCI that might be interesting from a scientific point of view, also for people that would study our new master's degree. Because to be honest, there's one thing bringing technology into the market. Like think about Amazon, not being a tech provider, being an e-commerce an e-commerce company, and the other thing is trying to use this technology for a certain purpose. Keep in mind, Amazon is using Alexa not because they like building AI tech; they like selling products. The goal was to decrease the burden of purchasing something online. That was the whole goal. We know now that it didn't really work out the way they wanted, but essentially that was the goal. In order to do so, we need something. We need a couple of social science characteristics to control here, and that brings me to some of the first studies we did in 2018, my students and I. The first was on authenticity. Authenticity. Can an AI be authentic? It's a quite difficult question because what means to be authentic is not always clear. So we basically posed this question to experts. A total of 12 experts working basically in research in the field of AI, and asked them what makes an AI authentic, real to a certain extent. And through this quite intense questioning and interviewing methodology, we identified 5 big characteristics that say, in 2018, that they thought would be very important to crack in order to make an AI authentic. On the one hand, good, strong conversational behavior. I mean, looking at specifically chatbots, I have to admit most of my work is in the field of chatbots and digital voice assistants. So strong conversational behavior is one of these characteristics that we have to crack. And by now, I think we have done that. Learning from experience. So this ability to actually relate back to something that was said before, that we humans can do. But at the time, at the beginning of these dialogue systems, they were not really able to do this. It was a very, very tricky task. Then something that is quite relevant, and I think it's something that is not yet solved, being transparent. Being transparent about what I want as an AI. Am I sort of a psychotherapist? Am I a shopping assistant? Being true to yourself, essentially, transparent, and number 4, coherent. Something that we see with ChatGPT. I'm getting to ChatGPT in a minute. We don't really see in ChatGPT. ChatGPT is not coherent at all. You ask the same question and it comes up with different answers every time you ask it. And the last bit, I'm not so sure about the last bit, to be honest. Anthropomorphize. We have seen that AI developers, AI engineers still, and have been for 60, 70 years, trying to anthropomorphize their technology, so make them human-like. I personally believe we are beyond that. I think we should actually get away from this anthropomorphizing. It makes, to a certain extent, makes it easier for people to actually talk to an entity, but knowing that this entity is not really a human, why don't we use the capabilities that we have at our hands to make it something else than a human? But that probably takes a societal shift for it to be real. But these are discussions that we are currently having in research. This brings me to another study we did a bit later. We looked beyond authenticity. Authenticity is one part of one sort of element of what we call social intelligence. And now we tried with an additional study, a slightly more extensive study, to understand what it is that social intelligence in conversational agents could be. And so we did a Delphi study. We recruited 21 experts from around the world, half of them more or less from academia, the other half from industry, and asked them about characteristics of authenticity as well as other aspects of social intelligence. So what makes an AI, what makes a dialogue system, a chatbot, digital assistant, socially intelligent? And there's 14 characteristics we identified through this Delphi study. By the way, a Delphi study is basically a repeated interview study. So we have 3 rounds of interviews in order to get to find a shared opinion, essentially. I don't want to go through all of them because time wouldn't permit, but a couple of interesting ones. Context-related actions, the first one. So context awareness is one of the things that AI developers, AI engineers have been trying hard to solve for a long time. And context in dialogue is pretty difficult because apart from the voice and the dialogue data, we don't have any other measurements we can take unless we have some sort of setup where, we have other sensors in the room. But context awareness is something very, very relevant. And we humans, we are context aware. We react to other people coming into the room. We change our behavior as soon as we understand there's maybe a person with a different kind of language entering the room or a conversational behavior. We basically adapt. We don't have machines yet that are context aware to that extent. Another one, let's say, justifiability, something connected to what we heard earlier with being transparent. Justify your actions. If you're thinking about an AI, ChatGPT, giving advice on a certain question, then I want for this technology to actually justify any kind of advice it gives. Why do you give this advice? And do this in a transparent manner. Or, for example, the last one, individual personality. I think it's a big one. Can we come up with a personality for AI? Can an AI have a distinct personality? What makes a personality? Just think about a chatbot that was developed for a specific company. So how does this chatbot present or represent the company? If I'm standing here as a faculty member of MCI, so I've been indoctrinated by MCI, whatever spirits and MCI behavior, so I represent MCI. But can a chatbot represent MCI? Can a chatbot represent any company? So what gives it a personality to a certain extent? Last study I want to quickly talk about before we make another jump. That was one that was recently published after ChatGPT published, but done before ChatGPT. Again, focusing on this personality aspect, personality on the human side, as well as trust and whether there's a connection. It was a quantitative study for a change. We did an online survey with a total of 367 participants and asked them about how much they would trust Alexa and other kind of dialogue systems. We used, existing construct-based questionnaire constructs, so basically questionnaire items that we knew they would be validated and they would work. And we tried to cross them with personality issues, so personalities of participants. You might know about the big five personality items. We use those big five and try to find whether there's a correlation between the big five personality characteristics and people trusting or not trusting into an AI technology. And we found that personality didn't play a role at all. I mean, honestly, we didn't find any connection here. We even found that not that the technology affinity or being very technics savvy and being very much accustomed with technology didn't make a difference either. What made a difference is whether, in general, people would have a certain belief in technology in general, not whether they use or whether they are very keen on using technology, but whether they trust in general that technology is good for us. If they trust in general technology is good, they would also trust Alexa and Siri and potentially ChatGPT. Well, speaking of ChatGPT, 2020s, we all know this nowadays. We all fear it, in academia at least, because our students all of a sudden cheat like hell. No, I wouldn't say that, but it led to a big change. So now we have a lot of the things that have been found out by our studies are solved now. We have really good communication behavior. The way ChatGPT produces text, generates text is really impressive. There were studies saying that, the average output of ChatGPT is better than a native English-speaking student at bachelor level. So this is actually really impressive what technology offers here. It's not that everything is correct. You have to really highlight that a lot of things that come out of ChatGPT are simply false. But the communication behavior, the language it uses, is very impressive. Which brings me to some more studies. One study that actually was quite interesting was done with a bachelor student of mine. We looked at whether it makes a difference when I give a face to a chatbot with respect to what people say. So we were looking at slightly more sensitive topics. If you think about psychotherapy, for example, people, in order to get help, you need to open up. You need to talk about your problems, and that can be very difficult sometimes. Sensitive topics. And the hypothesis was that if I change the sort of appearance of a chatbot, go away from the text to sort of a visual experience, that might actually change people's communication behavior in terms of how much they would give away, a sort of reveal about their problems. And we found that in this specific study, we compared basically sort of a non-representation, so this is the kind of ball on the right side, with a sort of a human face, was not animated, just a picture of a woman, and this kind of robot-like sketchy representation. And we found that what the robot-like representation actually led to the highest number of missing answers or elusive answers, whereas the woman led to answers that were had a higher level of depth, measured on a sort of an objective depth scale that you find in literature, as well as a greater breadth in the answer. So essentially, in our case, it would open up people to a certain extent. They would, be more open to talk about their own problems, which is a good thing if you want to get them to talk. Kind of a social science problem connected to technology. Next study, and that was a very applied one, again, fitting very much our new master's program, very applied. We thought about traveling. It was just before, the vacation time in summer, and we thought, well, would chatbots be a good thing to be used by an airport? So we used a local airport in Innsbruck, a very small airport, a very local regional airport. And my student was standing in line, and asking people, whether they have a minute or two to answer a questionnaire. They were waiting for a security check, so everybody has time when waiting. So we collected 119 responses from travelers, real travelers, so people that really used the plane, on whether they would trust and accept an airport chatbot, to help them with all kinds of things. Turns out they were all more or less familiar, or most of them were familiar with chatbots. They've used them already, and when it comes to real-time feedback, when it comes to delays of flights, when it comes to luggage questions or questions regarding parking or transportation, they would be happily using a chatbot, no problem at all. When it comes to more sensitive topics where you probably want some human touch to it, they would not really see any use for it. In the end, it comes down to a utilitarian factor. If it's useful, we use it. We trust it's fine. The airport releases it. It should be, the information should be correct. Everything is fine. We would use it. It saves time at the end. Funny enough, we also talked to the public relations officer of the airport, and they said, well, we would never ever introduce a chatbot. We need the human touch. We need to engage with our customers. So there's a slightly different perception on the business side of things. Last study, and I'm almost done. That was a challenging one. That was the latest one I published, or we published, a student of mine. Very important one when it comes to gender balance and inclusivity and discrimination and so on. We were looking at how much the voices of Alexa, Siri, and so on. You already see the Alexa, female, Siri, female. So most of these voice assistants have female names, so they should somehow represent a female, role to a certain extent. They are modeled after serving working behavior, serving jobs, being my secretary to a certain extent, which has a sort of female connotation to it, even in the year 2024. And we were thinking whether these sort of female voices and female names would somehow be linked to also stereotypical perceptions. And we found yes. So we basically played samples. We used a questionnaire survey again, 318 participants. And we asked them basically on gender spectrum and stereotypical gender roles, and to judge basically a voice based on these roles. So we recorded samples of a female voice, of a male voice, and of a non-binary voice. So a voice that was specifically adapted to the point where it was not being female or male, which is very difficult, by the way. We worked with a company in Belgium for this, and they adapted basically the voice parameters, the so-called F0, F1, F2 scores, in order to make it sound more neutral. And we found, well, the male voice did not, elicit any sort of male stereotypes. The non-binary voice also didn't elicit any stereotypes, but the female voice elicited very much female stereotypes, which is something that we should actually in the future may probably consider and maybe push for more non-binary voices in these kind of technologies to be more inclusive. Okay, that was it basically from the past studies. I have just 3 things that I'm currently working on with my students. One is actually very much with people here at Haga Helia. We were looking at, user experiences and acceptance of using AI-based essay grading systems. So basically students that are graded by an AI. Then I have one study currently working on the impact of explainable AI on trust miscalibration, so over and under trust. So do I trust ChatGPT too much or too little? And last but not least, on something connected to knowledge workers and their use of generative AI and how this changes their perception of quality of the work that is produced, whereas as well as sort of the responsibility to take for the work they produce with these generative AI tools. And I think that was it. Probably over time.
Nope, you're about spot on. So
I'm happy to answer if there's any questions in the room. I'm happy to answer.
Thank you, Stefan. I'm sure we do have some questions from our resident AI experts here in Haga Helia.
Thank you, Stefan, for such an informative talk. So I just have a quick question. In fact, 2 questions. So as you know that the capabilities of large language models are increasing. So our interaction with large language models is continuously increasing. For example, we have more interaction with OpenAI models with their new real-time API. And recently, Anthropic released a new Cloud A model, which can even control our computer and can execute the commands. So how do you see the future of large language models, especially in Europe, when the new AI Act will be in place from next year? Because they lay special emphasis on transparency and responsibility of AI models. And some recent studies show that these large language models, including both proprietary and open source, are nowhere even close to it. So how do you see the future? So the other question is, how do you see the creativity and reasoning of large language models? Because some studies show that large language models can generate the same novel ideas that can be generated by humans in many cases. So do you think that we need to redefine our concepts of creativity and reasoning in large language models era? Thank you.
Yeah, thank you. That's a challenging question, actually. Reminds me of some of the discussions we had yesterday in our, entry interviews for our new master program. Because some of the people that applied to this program actually have exactly this fear. They say, well, I work in marketing and I fear that my job is being replaced by GenAI. And as you correctly said, many of the jobs can be done by GenAI tools because, it produces quite creative answers, creative text, and pretty good in doing this. The AI Act, the elephant in the room. I don't know. I'm a bit worried, to be honest. I'm in favor of the kind of principles it tries to integrate into the European sort of data space with data protection, with fairness, with respecting people's privacies and so on. No misuse of data. At the same time, each and every AI engineer will tell you that without that we're basically falling behind. And I fear a bit that this is happening with these. Unless we find the holy grail of building our own models in our corners with the AI Act, I fear a bit that the companies in Asia and in the United States are overtaking us left and right when it comes to these kind of technologies. I fear. I'm not saying that. I have a certain fear. Maybe I change my mind in a couple of years. One thing we could do, I think, And that's one thing my colleagues and I have been working on as well. And I know you guys here in Haaga-Helia also to a certain extent, introducing more transparency into these Gen AI models. We have picked up an idea from 20 years ago, going back to something called ontologies and taxonomies, and trying to really actually to make the reasoning of these AI models more transparent and reduce hallucinations. So basically try for them to work on actual data knowledge graphs that can be displayed. I have a prototype on my laptop that basically shows the first sort of tool that we have developed, where we have a sort of a graph of the kind of connections it made in order to compute this answer. And I think that's an interesting thing to look at, and maybe that's a solution for us. That might be something, but I don't know. Can't predict.
Nope. Sorry, we have one more question from Lily. Sure.
Thank you. So I have a question regarding the first part of your presentation, the history of AI. So about the ELISA, for example, because it was quite simple. It just was taking the one part of the utterance that the person had said, and then it was repeating, and then it was really able to mimic a psychologist. So there's a tendency in us humans to anthropomorphize also. So even though it might be a very stupid bot, which is just repeating some hard-coded information, but if it's in a bot, we might think, okay, this is really something AI, and this is really looking like a human. But now that AI is very much there, do you think there will be also a tendency to think the other way around? Even though there is a human answering to us at some cases, we will be thinking that, oh no, it's a bot, it cannot be a human. Do you think this will affect the perception? You have been studying a lot of the human acceptance, trust, and perception. So do you think that this will turn the other way around, so that we will not be anthropomorphizing, but we will be robotizing and AI-tizing humans from now on?
That's actually a very, very good point. I read, I'm not sure whether it's true, but I read about a case or a situation where in the United States they actually forced their Alexa models to ask for more politeness. Why? Because when kids used Alexa, we all know that when the first time you use a digital assistant, the first time you try all kinds of things, you are very polite. You anthropomorphize a lot, and as soon as you figure out, well, you don't need to be polite. You don't just give it a command, and so kids turn to these commands. And there's a certain danger that, you lose your ability of communication with people, because if you don't know anymore whether this is a person or a human being, you might actually become very impolite with other people as well. And that's why I believe it is quite important, coming back to the beginning of my talk, it's quite important to let people know whether they're talking to a machine or to a human being. It may very well be that we still with a machine we anthropomorphize, but we know it's a machine. So when there was a study with Japanese senior citizens that attached themselves to these Aibo robot dogs, because they wanted something to play with, and they built up a feeling for this, and they walk the robot dog. That's the way it works, and it made them happy. And if you think about, I'm older than many other people, but I still remember Tamagotchis, right? You remember Tamagotchis? Those little eggs. People are really, they cared about the computer game, not, the egg not dying and these kind of things. So we do get attached to technology, but I don't think it's bad, as long as we are transparent about this. And then this should not happen, that we roboticize basically humans, which I think is a very bad thing to do.
That's great. Thank you, Stefan. But we're going to move on to our next. So thank you, Stefan.
Thank you.
So I think we're having some good conversation with some good information, and we're going to continue now. And I'd like to invite Professor Jan Majir from the Technical University of Košice to have a talk with us today on the topic of giving people the education they need, the role of social robots. So please, Jan, you're welcome.
Thank you very much, William, and thank you for inviting me and giving me this opportunity to present some of our research and how we think about social robots. And maybe it's sort of a call to action to reinvestigate how we think about AI and how it can influence business and the future. Because when we talk about AI for business, we immediately tend to think about, okay, how we can use AI to automatize some processes. We never discuss how we can use AI to prepare people better, because I think the best thing for companies even nowadays and for business is to have employees who are full of skills, who are able to adjust really quickly and who can use close to their full potential. And we will be discussing a little bit about how social robots can aid in education. So our research goes back a number of years now, almost 10 years, and I will be discussing some of that. But first, let's look at the educational part of it. So if you look at different types of practices, and there's a huge literature of how to optimize human learning, what happens in most schools and in most households when kids have to learn something, it's just rote repetition, random practice. They just do things over and over again and hope that sooner or later they will find a way to understand it, or they will get better at these things. But that's really not the best way to do things. And actually, even though you learn something in the early phases, then if you just keep repeating the same stuff, in the best case you will stagnate, and most of the time you will get worse at the thing you are doing. That's, for example, that was also shown, for example, in the medical field, that doctors who have a long years of experience, when it comes to diagnosing a specific disease, they are worse actually than doctors who just started out. Then the next level is purposeful practice, where you say that, okay, I want to get better at this sort of thing, and then I will focus on it and I will practice and I will not stop until I get better. And then the highest level is deliberate practice, where you also reflect on how you're doing. So if you could look at deliberate practice, the main thing is that you get constant feedback, because with rote repetition you get feedback only at the end, like, did you manage to solve this task or not? With deliberate practice you get feedback already during your process of solving a problem or during learning. A very good example of deliberate practice is how we are teaching music to kids. Like when they are learning to play an instrument, they get instant feedback, a lot of guidance, and that's why they can get better at playing an instrument very quickly compared to other subjects that they face and at schools. Deliberate practice and also purposeful practice, as I mentioned, targets weaknesses. So you have to sort of analyze how you are doing with the task or with the skill that you are learning, and what are the things that you are not really good at, and focus on those things. So of course it's not very enjoyable, but it is very useful. And to optimize your learning, you must always be performing just beyond your comfort zone. Because, of course, if you are faced with some problems that are too hard for you, you will not enjoy the process, you will get frustrated, and you will stop learning. But if the challenge is just of the right complexity, then you will learn a lot and you will enjoy the process. And with learning, of course, you have to target your mental representations and how you think about the skill that you are trying to learn or you are trying to develop. And the deliberate practice is actually structured in a way that will develop these representations to give you the opportunity to master a skill. And for this sort of practice, you, of course, need certain levels where you can identify that you are getting better or you are getting worse. And of course, as I mentioned before, relating to feedback and relating to weaknesses, it should be personalized. So it's all things that, of course, in theory work really well. In practice, if you wanted to use something like this in school, you would need one teacher for every single student, which is not possible to do, of course. So maybe we can use AI and robotics and other technologies to solve at least some of the problems that education nowadays still faces. So if you look at intelligent tutoring systems, so AI solutions that want to optimize human learning or want to aid students in learning new skills, then basically what you need to do is, of course, you have to come up with an interface that is natural for kids and for students, and of course you have to model what they already know, you model what they need to learn, and you model how the tutor or like how this tutoring system will adapt their learning. And of course, that's the basic idea that you can see on the left side from your point of view. And then you have the self-improving program and the adaptive teaching system that is learning actually during the interaction with the student and gets better and better at teaching kids and students generally. But when we talk about adaptation, we need to make a distinction between two basic types of adaptation, and that is general adaptation, where you program a system to work in a certain way, and then based on the experiences, the system will get better and better at doing this thing, but it will change its behavior the same way for every single user. So it is very goal-oriented. You tell the system what problem it should solve, and then it will learn the best way to do or solve this problem. And on the other hand, we have personalization, because you don't want to come up with a one-size-fits-all solutions, because that will be not optimal for each individual user. So personalization is about adjusting on top of this general adaptability, adjusting the system behavior to users' needs and preferences. And for that one, in the AI field, usually reinforcement learning is used, which is a learning paradigm where you have the adaptive system or an agent that is interacting with an environment and learning from the environment's reactions. So the basic principle is the same as if you are trying to teach a trick to your pet, or if you've ever tried to teach your dog a trick. That's exactly how reinforcement learning works, that an agent observes its environment, and based on the environment's reaction, it sort of gets some rewards, and of course it learns the behavior that gives the most reward. So in intelligent tutoring systems, what usually happens, it's quite counterintuitive, but what happens is that you give a positive reward if the system poses a question to the student that they don't know the answer to, because that's when learning happens, if they come across something that they don't know yet. And our experiences go back, as I've mentioned, about 10 years, and the first robotic system that we used was using this social robot now, and we set it up in an elderly care facility for cognitive therapy. Because what happens is that if these older people, they don't really use their cognitive functions as much as they should, then we can see a deterioration and sooner or later an onset of dementia. So what happens is that they have these cognitive exercises, so simple games, for example, as in our case, where the therapist actually just names a letter, and then the senior has to name either a fruit or an animal whose name starts with the given letter. And we were looking at options like, could we use social robots to automate this process? And what happened actually was that the robot was at first teleoperated in real time, so supervised in real time by a person from the room next door. And then based on the rewards that this teleoperator was giving, the robot was learning and adjusting its behavior. It was just personalization, so different sort of outcomes. It could express different sort of emotions, and there were different expressions of these emotions, and the robot just learned like which subject preferred which reaction or which expression of the given emotion. This was, of course, before the time of large language models and everything, and the speech recognition wasn't very reliable, so there still had to be this human supervision to evaluate the answers of the elderly, and now we could be building on these results and to automate even more of this process. Then another research that was done actually as a bachelor's thesis at our department was a language learning tutor, because social robots are usually used in language learning because that's a well explored field of study, and there's a lot of theory of how to optimize language learning. And in our case, it was a translation game, so the robot named or told a word in English or in Slovak, and the kids had to translate this word into Slovak or English, so into the other language. So it was used for vocabulary learning. And of course, we wanted to automate the whole process, so we used speech recognition, and there we were a bit wary about the pronunciation because, of course, kids, when they are learning, they can make mistakes. But after consulting with their teacher, we agreed that, okay, we will only accept the completely correct pronunciation because that's actually the only correct answer. And what was very important was that the robot was always providing feedback, so it told the kids if it was the correct answer or not, how they were doing, and trying to motivate them. So our methodology was that we had two different types of mode. For our system. There was a training mode where they were just learning the new words and repeating them. But of course, there was an adaptability in that the system would identify which category of words the kids weren't really aware of or didn't really know, and they would get more questions from this category. So it was just a simple adaptation, very straightforward. But we were expecting to see some development compared to just simple rote repetition where they go over a list of words. Then we had the testing mode where we just asked them 10 questions from the fields or like the categories that were used during the training, and we evaluated their answers following the Slovak grading system that is used at high schools and elementary schools. So if 90+% of the answers were correct, they would get the best grade, so grade number 1, and so on. There were different levels. So in our experiments, we had 31 students who were studying at the 8-year high school, so they were between 11 and 13, so just about the time when they've been learning English for 2 or 3 years, typically. We had 17 boys and 14 girls, and they had the first interaction with the testing mode just so they could get used to the robot. Once again, we used the Now robotic system. And then the 10 participants who had the worst results used the adaptive selection for the training mode, and then we retested every student again. So if we look at the results, this was before the training mode, so the average grade was around 3.5 for the Slovak to English translation, so just a bit less than half of the answers were correct. Regarding the grades, and 51% of the answers were evaluated as correct. But what happened was that because of mispronunciation, we also checked the logs, and we could say that okay, so about 70% were almost correct. So they got the correct word, but they weren't able to pronounce the word completely correctly, and because of that, the system wasn't evaluating it as a correct one. And then in English to Slovak translation, we could see that okay, of course, the difference was a bit smaller because of noise and background noise. There were some issues with speech recognition, and there the average grade was about 2.5. But after the training mode, we could see that, for example, the percentage of correct answers for English for these students who tested this adaptive robotic system rose from 40% to almost 80%. So we really saw a huge increase, and we could see that they really learned the categories that were causing them the most problem in the beginning. So we could see that, okay, this approach is really useful, and we evaluated that the results that were already published in previous research from different universities and institutes really hold true, and this is an issue or like a potential application that should be investigated in the future. And then we tested a similar robotic system, but in a less formal environment, so not in a school, but in a local museum, where we have a robot set up that plays a simple game with visitors, where it within one game it poses or asks 3 questions, where in each question the robot just says, could you show me the image of a certain type of robot? So there are 8 robot types, as you can see, and there are 8 pictures in front of the robot, and the visitor has to show the picture that they think represents the given robotic category. And we wanted to teach the system, or for the system to learn to end up with target interactions which have 2 correct answers and 1 incorrect answer. So the 2 correct answers we wanted so the visitors will have a positive experience, and the 1 incorrect answer we wanted so they learn something new. Because that's, of course, crucial when you go visit a museum. And there we tried different systems. We wanted to try or also consider the emotion recognition and the facial expression of these people, but unfortunately the lighting wasn't completely enough for us to accurately measure the facial expression or the emotion of the visitor. So we were just looking at the answers, whether they were correct or incorrect during the first phase of the of deployment. So we used Q-learning, which is a very basic reinforcement learning algorithm, and we just considered the number of correct answers so far and the number of remaining questions. So if you consider these options, since we have 3 questions in one game, there are 10 possible states or 10 possible combinations, and there were 8 categories. So we had 8 actions, where one action represented that the robot would ask this same the given category. And we had a different reward setup. So we would give positive reward if we ended up in the terminal state where we had 2 correct answers and 0 answers remaining. We wanted to get a very negative reward, so -10 if people didn't have any correct answers at the end of the game. And for all other states, we just say it's 0, it doesn't matter, we are focusing on these 2 extremes. And if we look at the results, there you can see that in the first phase of deployment, we had 224 games, of which 96, so about 40% or 43%, had 2 correct answers. And after the adaptive action selection, we got this number up to almost 140, so about 60%. And you can also see that we have the number of the interactions where there were no correct answers. And if we look at the final deployment with multiple games, you can see that there the increase is even more apparent. So we had about 70% of the interactions ending up in the 2 correct answers category. So we sort of tested that, okay, social robots can be used in formal and informal settings. But now, of course, we have large language models, so maybe that will open up the field, and we can use them even more for these tutoring systems. But the thing is with large language models that, okay, they solve the issue with the user interface. You can make more natural interactions with students, but you cannot model what they know and what they don't know. So if they, for example, if you want to teach them some mathematical concepts and you give them a task, or like a problem, and they are not able to solve it, you still have to identify which part of the process they are not comfortable with and why they couldn't solve the problem, and this cannot be done by large language models directly. Personalization could be possible through prompting. So now we have some final theses that focus on this issue. And the biggest problem with large language models is that they are very much black box solutions. We don't really know how they work and why they work, and what they do and how they do it and how to get the result that we want. It's not a straightforward. It's sort of like a trial and error, and that's usually not what you want to do when you are interacting with humans. So you don't want to run into unsuccessful trials. And the application domains are quite limited, so if you experimented with large language models, they are really good for English and language learning maybe, and they are really good with programming tasks, but the other ones not really good. And of course, if you have less frequently used languages like Slovak, for example, then you are really limited to the possibilities. So let's look at the social robots in a more realistic way. That, okay, we use this embodiment effect that, okay, students have a really good reaction to robots because they see something physically in front of them and they are focused and they are more motivated. But social robots are not really cheap. So schools cannot afford to buy a social robot for every single student. They are not scalable because of that. And there are no long-term studies. So what happens is that you get these very excited researchers who go to schools, they test these robots maybe for a week, and after that they pack up the robots and they bring them back to their universities and their laboratories. So we don't really know if this embodiment effect or this novelty effect would work on a long-term basis as well. And of course, nowadays you still have an issue with speech recognition, and with especially with kids who cannot articulate their answers properly sometimes, or if they are learning a language and so on. So it's still very much dependent on other functionalities. And for each application, you have to create a tailor-made solution if you want to model the kids' knowledge. So it's not really scalable, and we don't really have a general approach that can be used. So the social robot that we would need, and that's sort of our upcoming research for the next few years. That's what we are planning with a few students, also with bachelor's and master's thesis, that we want to develop a very simple, small tabletop, do-it-yourself robot that anyone could build. We want to make it an open. We have 3D printing now, so you could open up the field to a larger community. And of course, when it comes to the AI part, it needs to adapt really fast to different users to learn their preferences. But on the other hand, you have to ensure safety, so you want to handle the data on device. But on the other hand, when you have 100 or 1,000 people using a system, you want to sort of be able to aggregate these results and to adapt the system based on the experience that you have from every single one of them, and just adapt a little bit or do a little bit of personalization on top. So we have to find a way to handle this data security, but also exploit the knowledge that we acquire from these interactions. So this is what we are planning to do in the next few years, and something that might very well be a topic of our master's thesis or topics in the upcoming study program. So in conclusion, what's the good news is that even if you make a small improvement in the study or like teaching in education, it can go a long way, because it can leave a huge impact and huge results on a long term. And the good news is also that these results under laboratory conditions are promising, but now we need to explore them in a more realistic setting, maybe in a home settings and on the long term, and see that what are really the challenges of using social robots in education on a long-term basis, and how we can develop a solution that would be generally applicable for multiple domains. So thank you very much for your attention, and if you have any further questions, I will be happy to answering them.
Thank you very much, Jan. Again, some fascinatingly interesting content, and I think we have a question from the audience here in Pasila. Yeah, the best student of the day, Lily.
Thank you. I have been studying hard to get to this nomination, so thanks. So I have a question. It's a rather practical one. So thank you for the very interesting talk first. But I was wondering about the hardware and software that you were using in these experiments. I saw some robots. They looked a bit familiar. So I was wondering about those. And then about the software, you had this Face API there. So it would be really interesting to know which packages you are using, what programming languages and frameworks, and also for modeling, especially the learner, what you use to model the learner, to model the domain that has to be learned. So a little bit to see how this all has been implemented.
Okay, thank you very much for the question. So when it comes to hardware, so far we've been mostly using Now robots, which are like a very good and programmable robotic platform, but unfortunately our Nows are quite old now, so they are not as reliable as they used to be. So that's also why we are looking at other options and developing maybe our own simple solutions where we can target the things that we want to program. As for the language, we are mostly using Python, and for speech recognition, we experimented with the Google speech recognition API, and also now has some inbuilt speech recognition that works really well for English. For Slovak, they don't really have the support. They have the support for Czech, and the two languages are kind of similar, so we can adjust a little bit some parameters, and we can introduce some tweaks and and then we can use it for Slovak in some way. For the emotion recognition, the Face API, we were using actually the Microsoft Face API, so that's like a commercial solution. But we also tested our own models that are able to recognize these emotions. But for these things, we are usually opting more for commercially available solutions for these supporting functionalities.
Okay. Thank you very much, Jan. And thanks for coming all the way and for giving your talk today. Thank you. Okay. So we're going to have our final talk today from our very own Lily Ainemo, the best student in the class today. What affects study completion times? So please, if you have any questions for Lily, don't hesitate to ask her. The more difficult, the better. Lovely.
Okay, thank you. Okay, so I will be presenting now some research that we have been doing. So as William presented in the beginning, this hub is about, among others, about joint education in Ulysseus and also joint research. So this is about the research part. And so this is a learning analytics approach based on building models from data. And here we are really looking at how to build an analytics pipeline in a University of Applied Sciences. How could we do that? And also then we are building a model and analyzing the factors that might affect study completion times. So as we know, there's lots of data available nowadays from many different sources because of digitalization. And we could mine the data, for example, to investigate study paths, meaning what type of courses students do take or what kind of studying is popular. For example, the pace of studies, is it popular to study or is it good to study a lot in the beginning and then to have a more relaxed pace at the end, and bottlenecks. Is the thesis a bottleneck or not, for example? So all kinds of interesting issues could be studied from the data. And these were the questions we had in practice in this research. So we were thinking in the first place, how could we use this data? And if yes, how? What kind of environments and processes and tools would be beneficial for learning? So how should Moodle, for example, be used? Which practices do best benefit learning? And what kind of pedagogical practices would improve learning outcomes? And because obviously better learning speeds up studies and also it benefits the students and the university and, of course, the entire society. This is a very well-researched topic. So there's lots of studies on this and very much is on analyzing MOOCs because MOOCs, naturally, massive open online courses. Of course, they create lots of data that could be mined. And that's very popular. And also MOOCs typically have this challenge that typically students do drop out after a couple of weeks. So it's also interesting data set to know what are the possible bottlenecks for study interruption on a course. Okay. But here our idea was really to study the entire path of the student to get an overview beyond one course. And we know that there exists also software for that universities have been putting in place to actually use some of their own data. For example, in the United States, there is an example of this software where the students themselves can monitor where they are doing well and where they might possibly have some kind of risk of dropping out. And then if they wish, they can click on the button where it says that they are possibly dropping out, and then they could get some instructions on why is this button yellow, for example, here in the picture, and what could be done, what the student herself could do to make the button again green. So we are really on focusing aspects that the student, him or herself, can affect. Okay, so we were looking at data and students, and then we were using a cloud service to do all this data processing and machine learning from the data, and researchers only got very much processed data, so we did not get any access to the original data. So that's why we had involvement of this IT department, so that the IT department was handling all the data that the researchers, of course, would not need, or that should not be accessed by other people. Okay, but then to go to the actual model, so we built from the data a model for predicting the study completion times. And then in the model, we had variables. In total, selected 42 variables automatically from the data. So based on statistical measures, these variables were selected from the original about 80 or so variables. So for example, if two variables correlate very much with each other, we could drop out the other one. So it was statistically determined. And then we ended up having variables from Moodle, from grades, pace, which is the student studying in the beginning more, or in the middle, or at the end more. So what kind of pace is there? And then about study related is what is the study program and such. And then there was some background data. So here it really, and from Moodle, we were concentrating on the topic of diligence in respecting deadlines, because it has been researched that diligence in respecting deadlines typically is a sign of shows a correlation with self-efficacy, and this is an interesting variable to study. Okay, and then we were modeling this with the CatBoost software and using regression analysis. And here we are predicting the length of the study, which is on the x-axis, and then the prediction is on the y-axis. And as you can see, and we have semesters as the actual study duration, which means here that, for example, 5.0 means 5 semesters, which is then 2.5 years. Okay, and then now this is maybe the most important part is coming. So we got an accuracy that you saw in the previous slide, I think, of the model. It was pretty accurate. The prediction of how well it could predict the study duration. But then we were really interested in the features. So the most important features that the student himself could affect, that also have a correlation with the study, with the study duration. And so we used the SHAP method to do this. And here in green, you can see those which the student can affect himself. So we have, for example, variables related to the pace of studies and to the diligence in respecting deadlines and such. How many courses are in Moodle, because not all are there, and how many credits the student has, and so on, and the course count. And then here in red I have those which the student cannot affect him or herself, and these we were not interested in. But of course, in the model we did have these variables so that the accuracy of the prediction would be good. Okay. So and then in the data we saw, for example, how to read this, that the impact of student age. We saw that in our data set, which was bachelor students in Haaga-Helia, the younger, the faster the graduation that was in the data, and then between 30 and 40, we had the slowest group. So you can interpret this graph so that it is the slower, the higher it is. It is the curve, and then here you can see the age. So we can see here that the curve is going above 0. So here at about, 25, and here it gets slower, the pace of studies. And when it's below 0, then it's faster than the average. And here we have very little data points, as you can see. So when it's very dark blue, then we have lots of data points. Okay. And then we looked at virtual studies also. So in our data, it showed that if the number of virtual studies went up, the pace in studies got slower. And this did not take into account the COVID impact, because this was not reflected in the course data. So the course was still marked as a face-to-face course, even though it was due to COVID, a virtual course. So we did not change any course codes in the data during the COVID. And then here you can see an overall graph regarding the virtual studies offered at Haaga-Helia and also the virtual studies accomplished during the years at Haaga-Helia. And then next we can see the effect of grades, and here you can see the better grades, a faster graduation, but not too good grades. So I guess this is also very intuitive, that if one is aiming for the perfect grade everywhere, the studies will become quite slow. Okay, but also even a small number of failed grades or bad grades seem to be in correlation with slower study times. And this was the diligence in returning assignments in the Moodle. And here again we can see that if the student did return these assignments 7 to 14 days before the deadline, then he or she was faster in doing was doing the studies. Sorry, this is very sensitive. So here is the spot where the student is performing the best, and here is the number of days before which she or he is returning the assignments. And here we can see that if the student has returned, for example, 40% of these of the assignments before only 6 hours, the student that affects very much in lengthening the study time. So this is the graphs show what was also our intuition, that respecting the deadlines is really something that is correlating with rapid completion, and being always in the latest 6 hours is also correlating with not so rapid completion times, and this is also something that has to do with self-efficacy. But maybe this was the most surprising result to us, which we did not expect, was really that a back-loaded study timing was the one that was really the most fast type of studies. So we divided the studies into 6 equal parts. So if a student studied 6 years, then one part is 1 year, and then if the student did study the most in the part 6, which is the last one here, then as we can see, if in the last figure, if about 30% or from 20 to 40% of these studies are done in the last year, if we have 6 years, then the study completion time is really the fastest. But then here, for example, we can see in the part 1 that if, for example, studies are done 30 to 40% in the first year, then this is slowing very much the studies. So a very eager start is slowing the study completion times in this data set. We have this kind of result. Okay. And then we used the model to tell us the optimal parameters for fictional cases. So, for example, here we have a fictional case of a 50-year-old lady who is doing some retraining. And so how should we choose these variables to reach the optimal results? So, for example, here we have 6 semesters, which was the fastest ones, which is 3 years. And then we can have 16 semesters was the slowest ones. So this is 8 years. And here we can see the blue are how to choose for rapid graduation. We see that lots of grade 3 and grade 4, some of grade 5, and then doing most of the studies during the 3rd, 4th, 5th, and 6th periods, and then submissions from 7 to 14 days before the deadline, so very much ahead of the deadline. Okay, so that was the results, and then for the summary, what can we conclude as conclusions from this? So this was one of the works that is really modeling the student behavior over the entire study time. Typically, only courses are studied, and we are really interested in the students, in the features that the student, him or herself, can have an effect on. And according to the model, the quick completion time was facilitated by light start of studies, good grades but not too good, submitting tasks on time, and low distance studying rate, so low virtual study rate. But of course, we do not have the background variables, which we know that very much affect studies, such as, for example, health issues and such. And also this was based on this data set and also on those variables from Moodle, for example, that we took for consideration. So we were really concentrating on on self-efficacy and studying the respect of deadlines. As we know, Moodle has hundreds of variables that could be chosen, but the other variables were just automatically chosen. Okay, and then in case you got interested in this, we have this publication in this Journal of Computing in Higher Education that you can read, and then also you can ask. This is the team that did most of the research. So with me, I was working in close cooperation with my colleague Janne Kauttonen, senior researcher, and the IT specialist Marko Vahtola also. So I'm ready for any questions in case you have.
It's great. Thank you very much, Lily. I think we do have a question from the floor, and Stefan is over here.
Yeah, thank you, Lily, for this very interesting talk. There's one thing I always ask myself when people present learning analytics studies. I would love to do these kind of studies, but how do you get them through ethical clearance?
I was expecting this question.
Okay.
I was expecting this. So this was approved by the ethical committee, and the researchers never get in hands the real data. So we had here these IT people who were taking care of all these all the data, and they are anyways doing it for the institutional research purposes, which is of course very different from academic research. So the institutional research, and then we would only get derived data. But yes, I knew that this question would come up. Yeah, but hopefully this answered this.
It's just because in a sense you want to build more personalized systems. You want to support the individual student in his or her learning path, but at the same time you're not allowed to actually build this kind of models because you're not given the data. This is actually really tricky from a researcher's point of view, right?
Yeah, this is really tricky. And that's why I think it's really something to do more maybe in the institutional research groups. So, and they are doing this, and they are not publishing the results. And it's also really more to do it with the internal development in the university, like the system I showed you about the United States. But there again, we know that the legislation is way more liberal and way different from the European one. So yeah.
Okay, well, I think that's it then. So thank you very much, Lily.
Yep. Thank you.
And I'll just wrap up quickly. So
yeah.
But a big thank you to all our speakers. They came a long way from Austria and Slovakia and Finland. So really appreciate the interesting talks. And of course, we will be hosting this webinar on the Ulysseus YouTube channel in the future. We hope it's a point of reference both for the information contained in the seminars, but also in reference for future applicants for the Master's AI. So please keep an eye on the YouTube channel. Otherwise, wish you all have a lovely Friday afternoon. Thank you to those who are here in person, and thanks to those online. And please keep an eye on the Ulysseus YouTube channel and also on the Ulysseus website for any further information. Thank you to our speakers, Lily, Jan and Stefan, for some really interesting points and points of view. And other than that, thank you very much. Have a lovely evening, a lovely weekend. Thank you, everybody. Okay, thank you.